10th Standard Geometry, Chapter 3, Circles. These modules will study sums on inscribed angle and cyclic quadrilateral. Let us recall what we studied in a previous video. The measure of an inscribed angle is half the measure of the arc intercepted by it. In this figure, we can see that the inscribed angle is DCB. An inscribed angle DCB is intercepted by the arc DB. Measure of the central angle DAB is 120 degree. Corresponding to the central angle is the arc DB. Now we know that measure of the central angle and the corresponding arc is same. So measure arc DB will also be 120 degree. Now inscribed angle theorem states that the measure of the inscribed angle will be half of the measure of the arc that it intercepts. So in this case, measure of arc DB will be 120 degree because measure of the central angle is also 120 degree. And by the inscribed angle theorem, angle DCB will be half of 120, that is 60 degree. Similarly, in the second figure, the measure of the central angle is 100 degree. Corresponding to the central angle, measure of arc DB will also be 100 degree. And by inscribed angle theorem, we can say that angle DCB will be half of 100, that is 50. Similarly, in the third, measure of the central angle is 140 degree. Measure of the inscribed angle will be half of 140, that is 70 degree. The second corollary states that angle inscribed in the same arc are congruent. So in the first diagram, if you note that angle DCB and angle DEB, both of them are inscribed in the same arc, that is DCB, or you can also name it as arc DEB. Both of the arc are the same. So both of these angles, angle DCB and angle DEB, are inscribed in the same arc. The corollary states angles that are inscribed in the same arc will be congruent. So if angle DCB is 62 degree, angle DEB will also be 62. In the second diagram, states the same thing. If angle DCB is 45, angle DEB will also be 45 as they are inscribed in the same arc. Similarly, if DCB is 55, angle DEB will also be 55 as both of them are inscribed in the same arc. Angle inscribed in a semicircle. We know that angle inscribed in a semicircle is a right angle or a 90 degree angle. If all vertices of a quadrilateral lie on the same circle, then such type of quadrilateral is called as a cyclic quadrilateral. Opposite angles of cyclic quadrilateral are supplementary. This is a statement of cyclic quadrilateral theorem. An exterior angle of a cyclic quadrilateral is congruent to the angle opposite to its adjacent interior angle. This is a converse of the cyclic quadrilateral theorem that states if a pair of opposite angles of a quadrilateral is supplementary, then the quadrilateral will be cyclic. And the last point, if two points on a given line subtend equal angles at two different points which lie on the same side of the line, then the 4 points are said to be concyclic. By concyclic, we mean that each point lie on the same circle. To summarize the last point of the recall, the theorem states that if 2 points on a given line subtend angles at two distant points which lie on the same side of the line, then the 4 points are concyclic. So for example, points C and D lie on the same line and they subtend equal angles. That is angle CDE and angle CFE. Both are 60 degree. In this case, all of the 4 points C, D, E and F will be concyclic. That means they will lie on the same circle. Let us start with practice set 3.4, the first sum. In the given figure, in a circle with center O, length of chord AB is equal to the radius of the circle. We have to find measure of each of the following. First, measure of angle AOP. Second, measure of angle ACB. Third, measure of arc AB. And fourth, measure of arc ACB. Let us start with the solution. In the figure, OA and OB are the radius of the circle. Therefore, OA will be equal to OB. In the question, it is said that the chord AB is equal to the radius. Therefore, OA equal to OB equal to AB. As it is given, AB is equal to the radius. Therefore, OAB will be an equilateral triangle as all of the sides are equal. Since it is an equilateral triangle and we know that the measure of the angles in an equilateral triangle will be 60 degree. That is, each of the angles will be of 60 degree. Therefore, angle AOB equal to angle OAB equal to angle OBA equal to 60 degree. Thus, the measure of angle AOB is 60 degree. That was the first part of the question. Second, they have asked to find out angle ACB. The measure of an angle subtended by an arc at a point on the circle is half of the measure of the angle subtended by the arc at the center. This is the inscribed angle theorem. So the inscribed angle theorem says that the inscribed angle will be half of the measure of the arc that it subtends. So in this case, angle ACB is an inscribed angle and that will be half of arc AB. Now we know that measure of the central angle and measure of its corresponding arc will be the same. So measure arc AB will be same as measure arc AOB. Hence we say that by using inscribed angle theorem, angle ACB equal to half of angle AOB. Note one thing, that angle AOB is the central angle, and in the previous part of this question we found out that angle AOB is 60 degree. So we just substitute in place of angle AOB 60. So half into 60 will be 30 degree. Thus the measure of angle ACB is 30 degree. The third part is finding measure of arc AB. Now we know that measure of the central angle and measure of its corresponding arc is the same. We found out the measure of the central angle, angle AOB, that is 60 degree. Corresponding to the central angle is the arc AB. So arc AB will also be 60 degree. As we know, measure of arc is same as the measure of its corresponding central angle. Thus, measure of arc AB is equal to 60 degree. The fourth part of the question is finding measure of arc ACB. If you look at the figure, we have to find measure of arc ACB, and note one thing, measure arc ACB is the major arc in the circle and AB is the minor arc of the circle. So if we use the formula, measure of arc ACB is equal to 360 degree minus measure of the minor arc. We know measure minor arc in this case is AB and measure of the minor arc AB is 60 degree. Therefore, 360 minus 60 will be 300 degree. Hence, measure of arc ACB is 300 degree. Let us start with the second sum of practice set 3.4. The question says, in the given figure, PQRS is cyclic. That is, quadrilateral PQRS is cyclic. Side PQ is congruent to side RQ, and measured angle PSR is 110 degree. We have to find measure of angle PQR. Second, we have to find measure of arc PQR. Third, we have to find measure of RQR. And fourth, we have to find measure of angle PRQ. Let us start with the solution. Since the quadrilateral is cyclic, and we know by cyclic quadrilateral theorem, opposite angles of a cyclic quadrilateral are supplementary. So angle PSR and angle PQR are opposite angles of the quadrilateral, and their sum will be 180 degree. Hence angle PSR plus angle PQR will be equal to 180 degree, as opposite angles of cyclic quadrilateral are supplementary. Angle PSR in the question, it is given to you 110 degree. So we'll substitute in place of angle PSR as 110. We'll take this 110 degree on the other side, it will get subtracted. So we get angle PQR is equal to 180 degree minus 110 degree, which is 70 degree. Thus, measure of angle PQR is 70 degree. Kindly refer to the previous videos for the theorem opposite angles of cyclic quadrilateral are supplementary. That is the cyclic quadrilateral theorem. The second part of this question is we have to find measure of arc PQR. Now, by inscribed angle theorem, we can say that angle PSR will be half of the arc PQR. So if you note one thing in the figure, angle PSR is an inscribed angle and it is intercepted by the arc PQR. Therefore, by inscribed angle theorem, I can say that angle PSR is equal to half of the measured arc PQR. Now, we'll take this 2 on the other side. So it will get multiplied with angle PSR. Hence, we can just rewrite the previous statement as measure arc PQR is equal to 2 times angle PSR. Now, angle PSR is 110 degree, that is given in the question. So in place of angle PSR, we just substitute 110. 2 into 110 is 220 degree. Therefore, we can say that measure arc PQR is 220 degree. So with that, we finish the second part of this question. The third part of the question is to find out measure arc QR. Side PQ is congruent to side RQ, that is given in the question. Arc PQ congruent to arc RQ. Next, measure arc PQ is equal to measure arc RQ. As if two arcs are congruent, their measures will also be congruent. Now, if you note in the figure, measure arc PQR is the sum of arc PQ plus QR. Hence, we can say that measure arc PQR is equal to measure arc PQ plus measure arc QR. Now, we know that arc PQ and arc RQ are congruent. So here, in place of arc PQ, you write arc QR as both of them are congruent. So from here, we get measure arc QR plus measure arc QR in the right hand side. So we can add this up the right hand side to get 2 times measure arc QR. Measure arc PQR is 220 degree. This we found out in the previous part of the question. So 220 in place of measure arc PQR, we substitute 220. So 220 degree is equal to 2 into measure arc QR. We take this 2 on the other side, it will get divided by 220. Therefore, measure arc QR is equal to 220 divided by 2, which is 110. Therefore, measure arc QR is 110 degree. In the fourth part of this question, we have to find measure of angle PRQ. So again, we'll use the inscribed angle theorem. So if you look in the diagram, angle PRQ is an inscribed angle, and this angle is intercepted by the arc PQ. Therefore, we can say angle PRQ is equal to half of measure arc QR. Measure arc QR will be same as measure arc PQ as it is given in the question. So in place of PQ, I have written arc QR. Measure of arc QR we have found in the third part of this question, and we got it to be 110 degree. So we'll substitute here in place of measure arc QR as 110. So half into 110 will be 55 degree. Therefore, measure of angle PRQ is equal to 55 degree. Let us move to the next sum, practice set 3.4, the third sum. In the question, it is said, quadrilateral MRPN is cyclic. Angle R is given as 5x minus 13 degree. Angle N is 4x plus 4 degree. We have to find what are the measures of angle R and angle N. So if you note in the question, measure of angle R and angle N is given, but it is given in a different way. It is given in form of an equation. So we need to use this condition, that is quadrilateral MRPN is cyclic. We have to use this given condition to find the measures of angle R and angle N. So let's start with the solution. It is said that MRPN is a cyclic quadrilateral, and we know that by cyclic quadrilateral theorem, the opposite angles of a cyclic quadrilaterals are supplementary. So if we add the opposite angle, in this case angle R plus angle N, we'll get it to be 180 degree since they are supplementary. As opposite angles of a cyclic quadrilateral are supplementary. We'll substitute the values of angle R and angle N that is given in the question. Angle R is 5x minus 13. Angle N is 4x plus 4 equal to 180 degree. So we'll add 5x and 4x, which will be 9x, and minus 13 plus 4 will be minus 9. So we get the new equation, that is 9x minus 9 equal to 180 degree. We'll take the minus 9 on the other side, it will get added. So it will be 9x is equal to 180 plus 9. So 180 plus 9 is 189 degree. We'll take the 9 on the other side, it will get divided by 189. And 189 divided by 9 is 21 degree. So x is equal to 21. So we have not yet finished with the sum. We have just found out the value of x. The next step would be substituting the value of x in each of these angles. In angle R and in angle N, we'll substitute the values of x. So angle R is given as 5x minus 13. So here in place of x, we'll substitute 21. So this will be 5 into 21 minus 13. So 5 into 21 is 105, and 105 minus 13 is 92 degree. Therefore, angle R is 92. In a similar way, we'll substitute the value of x in angle N. Angle N is given to you as 4x plus 4. So here in place of x we'll substitute 21. So this becomes 4 into 21 plus 4. 4 into 21 is 84 plus 4, and 84 plus 4 will be 88 degree. Therefore angle N is 88 degree. Thus the measure of angle R and angle N are 92 degree and 88 degree respectively. Let us do one more question in exercise set 3.4. This is the fourth question. In the given figure, segment RS is a diameter of the circle with center O. Point T lies outside the circle. So point T, if you observe the figure, point T is in the exterior of the circle. We have to prove that angle RTS is an acute angle. So if we join RT and TS, an angle will be formed, and we have to prove that the angle so formed is an acute angle. Let us start with the solution. First, we'll start by joining RT and R and TS. And suppose that RT will intersect the circle at P. If you observe the figure, we have joined RT and TS, and the segment RT is intersecting the circle at point P. Now, it is given in the question that RS is a diameter of the circle with center O. So, if RS is a diameter, this diameter will divide my circle into two semicircles. So, we can say that the upper portion is a semicircle. So, we can say that angle RPS is equal to 90 degree. The reason we can say that is by the theorem that angle inscribed in a semicircle is 90 degree. So this is the corollary of the inscribed angle theorem. So if you do not remember, kindly go back to the previous videos, and in that video I have explained the corollary of the inscribed angle theorem. It says angle in a semicircle is 90 degree. Angle inscribed in a semicircle is a 90 degree. Therefore, angle RPS will be 90 degree. Now, try to observe triangle PTS. Now, in triangle PTS, angle RPS is an exterior angle. Now, since angle RPS is an exterior angle and angle PTS will be its remote interior angle. Now we know that this is a property that states that the exterior angle of a triangle will be greater than its remote interior angle. Now in our given case, RPS is an exterior angle and angle PTS is a remote interior angle. By this property, we can say that the exterior angle is greater than the remote interior angle. Now, angle RPS is 90 degree. We have found out previously. We'll substitute in place of angle RPS, we'll substitute it as 90 degree. So 90 degree greater than angle PTS. We can rewrite this as angle RTS less than 90 degree. That is, in angle PTS, I've just substituted RTS because if you observe the figure, angle RTS is same as angle PTS. So in place of angle PTS, I've just rewritten it as angle RTS. So angle RTS is less than 90 degree. Now we know that an angle which is less than 90 degree will be an acute angle. Hence, we can conclude that angle RTS is an acute angle. Practice set 3.4, the fifth question. In this question, we have to prove in general that any rectangle is a cyclic quadrilateral. So, given any rectangle, we have to prove that that given rectangle will be cyclic. So, let us start with the proof. We'll consider, suppose ABCD is a rectangle. So in the figure we can see that ABCD is a rectangle. Now we know that in a rectangle each of the angle is a 90 degree angle, a right angle. Hence we can state that angle A equal to angle B equal to angle C equal to angle D equal to 90 degree. Each of them is a 90 degree angle. Now, if we add the opposite angles of this rectangle, angle A plus angle C, we know angle A is 90, angle C is also 90. So 90 plus 90 will be 180. Similarly, if we add angle B and angle D, that is the other pair of opposite angle B is 90, angle D is also 90. So 90 plus 90 will be 180 degree. Now we know the converse of the cyclic quadrilateral theorem. The converse of cyclic quadrilateral theorem states that if the pair of opposite angles of a quadrilateral is supplementary, then the quadrilateral is cyclic. For converse of cyclic quadrilateral theorem and the proof, kindly refer to the previous modules. So by converse of cyclic quadrilateral theorem, we can say that the pair of opposite angles, if they are quadrilateral, if they are of a quadrilateral, is supplementary. As we have proved here that the opposite angles are supplementary, we can directly state that the rectangle ABCD is a cyclic quadrilateral. Next we'll do the eighth sum of practice set 3.4. In the given figure, chord AC and DE intersect at B. If angle ABE is 108 degree and measure arc AE is 95 degree, we have to find measure of arc DC. To solve the sum, we need to know first a property. The property says that if two chords of a circle intersect each other in the interior of a circle, then the measure of the angle between them is half the sum of the measures of the arc intercepted by the angle and its opposite angle. If you observe the figure, the two chords called AC and chord DE intersect at a point B which lies inside the circle. So by this property we can say that the measure of the angle between them, that is in this case measure angle ABE, will be half of the sum of measures of the arc intercepted by the angle and its opposite angle. So that is angle ABE will be half of measure arc AE plus measure arc DC. We'll be using this property to solve the sum. So here in this case, if I take the 2 on the other side, it will get multiplied by angle ABE. So we are left with measure arc AE plus measure arc DC is equal to 2 into angle ABE. So what I have done is I've just multiplied this 2 on the left hand side. Now measure arc AE is given in the question, that is 95 degree. So in place of measure arc AE, I've just substituted 95. And arc measure angle ABE is also given in the question, that is 108 degree. So in place of ABE, I've substituted as 108. 2 into 108 is 216. And we take this plus 95 on the other side, it gets subtracted. So 216 minus 95 is equal to 121 degree. Thus the measure of arc DC is 121 degree.